Did not say check the chart. Now, how do I know it's an acid base? Because I'm going to have a hydrogen in the reactant side, and I'm going to have H2O on the product side. So let's look. Do I have hydrogen on this side of the reaction? No, I do not. So this is not an acid base. This is a precipitant. And because it's a precipitant, I need to go to the chart so I can figure out who is going to be a solid and who is going to be a liquid. So on your notes, on the very last page, here is our chart. So let's go ahead and let's look at that. Alrighty, I've got, and we're going to look at the product side. On the product side, I've got CDS and I've got NaNO3. So let's look. If it's going to be one of these, they are going to be soluble. That means that they dissolve. If it's going to be down here, that means that they do not dissolve and that they are going to be the solid precipitant. So I have a NaNO3 and a CDS. So let's look. CD and an S. CD, 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 CD. Nope. Let's look over here. CD. Nope, 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 nope. Okay, they didn't give me that one. Not a problem. But they gave me also on the product side, what else is over there? Let's go back and double check. The CDS wasn't there, but the NaNO3. Let's look for that one. NaNO3. No. Oops, no. Look at that. NO3. Okay. But common exemptions or exceptions. There's no exceptions here. Soluble compounds contain NO3. So if it contains NO3, it's pretty much going to be, it says here, soluble. What does soluble mean? That means that it dissolved. That means that our other one, the CDS, let's look down here. CD, no, CD, CDS, 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 CDS. There's an S. There's an S. There's some exceptions to the rules though. Compounds with NH4, the alkaline metal cations, Ca, Sr, and Ba. What did this combine with? Did this combine with any of those? No. It combined with CD. Since it combined with something that wasn't part of the exceptions, then that means that the S with the CD is going to be insoluble or the solid part. The NO3, there's no exceptions to the rules. I don't care who NO3 is going to combine with. He's always going to be soluble. So let's go back to our notes. So that means that the CDS is going to be a solid, insoluble, and our NaNO3, because of the NO3, it does not matter who he combines with, he is going to be soluble, no matter what. Okay, so here is my solid, here is my liquid. So let's go ahead and let's write that in and let's double check to make sure that it is balanced also. Now, because this is going to be insoluble and soluble, that means that there is going to be a S here for a solid. It's not written there. You have to write it. And this one is going to be AQ because it's aqueous. It's still a liquid, a solution. Okay? So let's go ahead and let's keep looking. I'm going to double check to see if it's balanced. Na, S, CD. Does the NO3 stay together here and here? Yes, it does. NO3. Draw my wall. 1 times 2 is 2. 1 times 1 is 1. 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. 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 Am I balanced? No, I'm not. On this side, I need some more NAs and NO3s. So look at this. How lucky am I? They're actually already together. So if I put a 2, 2 times 1 is 2. 2 times 1 is 2. Am I balanced? 2 and 2, 1 and 1, 1 and 1, 2 and 2. Now I'm balanced. And if you wanted to, you can put a number 1 in front of the other ones. Okay? Let's continue to practice because we're going to need to practice some more. I have Fe and S, iron and sulfur, is going to combine with hydrogen and chlorine. Now before I go any further, iron is going to be a positive charge. Now sulfur is a nonmetal, which is a negative charge. And if you actually go look at sulfur, sulfur is going to be a -2 charge because he's in group 16. But wait a minute. If you look at this skeleton equation right here, there's no 2 that crossed over here to the Fe. What does that mean? That means that it reduced to its lowest form, which is 1 and 1. So if it reduced, that means that this Fe must have a 2 as its charge. Okay? And then we have hydrogen and we have chlorine. Hydrogen's a +1 charge, chlorine's a -1 charge, so they crisscross and cancel each other out. Now I've got Fe and I have SH and I have chlorine. Now I understand hydrogen is a nonmetal, but where does he live? He lives in group 1 with the other metals. And because of that, then that means that my Fe is going to kick the hydrogen out and he's going to take his place. Because hydrogen acts like a metal, even though he's a nonmetal. But he acts like it. So let's come over here and I'm going to rewrite all of this number 2 and I'm going to draw a line over here just so I can make it a little clearer. I'm going to put number 2. So I'm going to have FeS solid plus HCl aqueous yields. The Fe is going to take his place. So in that case, it's going to be FeCl plus HS. There we go. Now wait a minute. We need to decide on the product side who is going to be the solid and who is going to be the liquid. How do I know I need to use the chart? If it was an acid base, it would have hydrogen on this side, and on this side it would have H2O, but it doesn't. So that means that it's a precipitant and we have to go to the chart. Now let's go backwards to that chart and I'm going to look for FeCl. FeCl. There's Cl, chlorine. I don't see Fe anywheres. Now, what's the other one? HS. HS. Look at this though. S is in the insoluble. Now, there's exceptions. Who is sulfur being mixed with? It's being mixed with hydrogen. So let's come over here. Compounds of NH4, no. Just hydrogen. Alkaline metals, no. Ca, no. Sr, no. And Ba, no. So since there's no exceptions right now to RSH, then that means that the sulfur is going to be insoluble, which is going to be the solid. The chlorine is going to be the soluble, which is going to be the aqueous solution. So let's go ahead and write that over here. Our chlorine is going to be soluble, which is aqueous, AQ, and my sulfur, doesn't matter who he's mixed with, is going to be my solid. Okay, that's going to be formed. Let's go ahead and let's look at this. I know this is a +2 - 2. I know this is a +1 - 1. Fe is going to be a, well, chlorine is a -1. Iron is a, and I apologize, I'm looking over here. Where am I at? Fe is a +2 because it's a +2 over here. Chlorine is a -1. H is a +1, and sulfur is a -2. So what do we need to do? We need to do some crisscrossing action going on. So let's do that. Cancel, cancel. They don't cancel, so a 2 needs to come down here. FeS solid plus HCl aqueous yields FeCl2 plus crisscross H2S solid. That's what we're going to write. What do we do for our next step? Well, we need a balance. FeSHCl. So let's go ahead and do that. Balance it. Let me help you. 1 times 1 is 1. 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 Fe. 1 times 1 is 1. 1 times 2 is 2. 1 times 2 is 2. 1 times 1 is 1. Am I balanced? No, I'm not. I need more hydrogen and chlorine on the reactant side. The cool thing is that they're already combined. I need a 2, so let's put a 2. Let's recount. 2 times 1 is 2. 2 times 1 is 2. Am I balanced? Check, 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 check. And if you wanted to, we can put a 1, a 1, and a 1. Okay? So that was question number 2. Again, if it's a double replacement, then if it has hydrogen by itself on the reactant and on the product side I have H2O, it's what we call an acid base. You're just going to go ahead and swap them, crisscross everything, and you're done. Balance. If it's not an acid base, then that means that it's a precipitant. In that case, you're going to write your skeleton 1 out. You are going to go ahead and decide who's going to be the soluble and who's going to be the solid that's, the one that's dissolved, that's soluble, and which one is insoluble, which is the solid. Once you find that out, then you can crisscross, then you can balance. So it's a little bit more steps that way. Let's look at example 3. We're almost done with the notes. It says here calcium hydroxide reacts with HCl. So calcium hydroxide acts with HCl. Whoa, wait a minute. Look at that. Hydrogen, HCl, that's an acid. So let's go ahead and let's look at that. Calcium hydroxide is a metal +2 charge. Hydroxide is a polyatomic -1 charge. Hydrogen is a +1 charge. Chlorine is a -1 charge. We're going to crisscross them, and we need to decide who is going to swap places. Calcium is a metal, so calcium is going to kick out the hydrogen. Okay? Calcium is going to kick out the hydrogen, and he's going to combine with the hydroxide. So let's look at that. Crisscross, don't forget. Ca, there's a 1. Hydroxide is OH, but this 2 is going to crisscross over. So OH2 plus HCl, because the ones cancel each other out, yields, I'm going to have my calcium kick him out. So it's going to yield CaCl. My Ca is a +2 charge. My Cl is a -1 charge. Crisscross those. So this really becomes a 2 down here. I'm going to draw a line here. Plus, what happens? My H is going to combine with the hydroxide, OH. And actually, what is that? H2O. So mark that out and put H2O. All right. So now we've got our skeleton equation written out. We know this is an acid base because I have an acid on this side with hydrogen, and on the product side I have H2O. What do I do for my next step? Let's balance. Alrighty, let's make sure we balance. Ca, I have, well, you make the decision. Over here I have O and H's, and this is a polyatomic, but over here I don't. So I'm going to go ahead and make my choice for me, and I'm going to have O and H's separate, and I'm going to have Cl's. There you go. Let's balance this out. 1 times 1 is 1. 1 times 2 is 2. Wait a minute. Because it's a polyatomic, I like to visually see it. OH, OH. So I have 2 O's. I have 2 H's. Plus there's another H. So I have 3 H's. Cl is 1. Let's come over here. 1 times 1 is 1. 1 times 2 is 2. H2O. I have 2 H's and 1 O. Am I balanced? No, I'm not balanced. All right, so let's go ahead and practice that. I need more H's over here. I need more oxygens over here. I need more Cl's over here. Okay, so I'm going to start with the Cl's. I have 2 on this side, so let's make it 2. Let's count up. 2 times 1 is 2 H's. So I have, I apologize, I forgot to count him. 2 OH's plus now 2 H's. Now I have 4 H's. And 2 times 1 is 2 Cl's. I apologize earlier. I forgot to count this H's with those H's. Let's look over here. I'm not balanced. I need more O's and I need more H's. So let's go ahead and put a 2 in front of it and let's see what happens. Okay. I have 2 H2O's. 2 times 2 is 4. 2 times 1 is 2. Am I balanced? Check, check. Check, 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 check. And if you wanted to, you could put 1s in the front. That is a balanced equation. Here we go. I apologize. I know there's like not enough room ever. Let's look at the next one. I have an acid, and on the product side, I better have H2O water. Now, hydrogen is a +1 charge, chlorine is a -1 charge. Sodium, Na is a metal +1 charge, and OH is a -1. It's a polyatomic. So when I crisscross everything, they're going to cancel each other out. But let's look at this. This is going to be the hydrogen acts like a metal. So he's going to kick out the sodium because metals can only replace other metals. So let's go ahead and write this out. HCl plus NaOH yields, who's going to do what? I'm going to kick that, H is going to kick out the Na, and he's going to move over with the OH. But do you see what's going to happen? H plus OH equals H2O plus NaCl. Okay? Now let's go ahead, and I apologize, I know I'm still going through these notes, but we're not done yet. Our next step is to balance H, Cl, Na, and O's. 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 So let's draw our walls. Let's look. H, 1 times 1 is 1. Cl, 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1 O, but there's another H, so 1 plus 1 is 2. Let's look on this side. 1 times 2 is 2. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. Am I balanced? Check, 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 check. I am all the way balanced. I could put a 1 if I wanted to. And do you see those last two was a little bit easier because we did not have to go to the chart because it was an acid-base reaction. All right, we're almost done. we're down to this back one, this back chart back here. Okay, it's just going to kind of help us a little bit more is what I'm hoping is what this is going to do. It says here, in true chemistry, there are only two major types of reactions that we focus on. Okay? So let's look at this. We're going to say types of reaction. Okay? Now, we are going to have what we call single elements or two or more elements. So single. And this one is going to be two or more elements. Meaning that all of our reactions can be broken into what we call a redox or not redox. Okay? Now, a redox is going to be what we call synthesis, a decomposition, a single replacement, a combustion. Okay? Now, the way that they look is synthesis is A plus B yields AB. Decomposition is AB yields A plus B. A single replacement is A plus BC yields BA plus C. And a combustion is AB plus O2 yields AO plus BO. Okay, that's just the generic breakdown of what it looks like. Now, not redox reactions are going to be our acid base or our double replacement. Okay, now if it's an acid base, we're going to have H, and I'm going to put B, plus we're going to have C and OH. This OH is the hydroxide because this H, which is our hydrogen plus our hydroxide, are going to yield H2O plus the other object or the other thing is a salt. Okay, now the double replacement over here, okay, which is a precipitant, is going to be the AB plus CD yields AD plus CB. And I'm going to put right here in parentheses, precipitate, which is a solid is formed. And you have to use the chart. Okay? We have to use the chart. Whew. I know. That was a lot. So here's our notes. Our notes are done. Okay? There is the PowerPoint extra set of notes that we have also. I will absolutely add those on here for you. I just needed us to be able to at least have all of the notes, even though we had most of them already in person. I just thought it would be better for us to go over all of them again. Your choice to decide to fast forward it or not, or watch the whole thing if it's going to help you out. Have a great day.